All right, let's rock and roll. This is video 2.6 on the maladies of the marrow, the diseases of the blood. Not all of them, of course. We're going to talk about three today. And these three, I think, really exemplify all of the stuff that we talked about, the importance of bone marrow, the importance of hematopoiesis, and the importance of proper B-cell development. So without further ado, let's roll. The first one we're talking about is leukemia. Leu refers to white, emia means blood. So we have white blood cells overrunning the blood. You might think, well, what's the problem with that? I like my white blood cells. They give me some defense. Well, let's go into why this is not good. So this is the proliferation of hematopoietic precursors leading to immune suppression and chaos. So 30,000-foot view here, go down to my tree. Basically, I get stuck either here, here, or here, maybe even here. So I don't produce any of my effectors. None of these are produced. Or even if they are, they're produced in very, very limited amounts. And you might be thinking, well, what's the big idea? This guy can become anything here. This guy can become anything this way. This guy is fine over here too. So what's the big idea? Well, the thing is that they're stuck there. They are stuck there. For whatever reason, that signal is not being produced, or there's a signal to make more of these and nothing downstream, what have you. All you need to know is that, well, these aren't specialized. This common lymphoid progenitor in no way is ever going to make antibodies. A common myeloid progenitor in no way is ever going to secrete histamine and heparin as a basophil does, or create nets like a neutrophil does. That's the whole point of differentiation. We have to select for those attributes. It's kind of like a video game. We select for those skill points. That level 1 character can become whatever we want, but it can't do the abilities that these guys can. So in effect, we have a bunch of cells that might be technically white blood cells, but they're not doing anything. They haven't learned how to do anything or differentiated. All right, so what's the initiation here? It's a genetic mutation in that hematopoietic stem cell. And that can do a couple things. It can either cause unregulated proliferation. So I don't remember all the stages of the cell cycle, but I don't remember, so bear with me. I think it's like G1, G2, S. All we're doing here is that this signaling pathway gets messed up, so I just keep proliferating. I get no signals in my intercellular machinery to tell me to calm down. The only signal is make more. Make more. And a mutation in the cell cycle that says make more with an unregulated capacity, that's literally cancer. That is... Whoopsie, that's way too thick. That's cancer. A mutation that knocks out whatever regulatory capacity that you had for controlled proliferation. But this makes sense. This makes sense why it could happen here. These hematopoietic stem cells are constantly dividing. They're constantly differentiating and going down the different pathways to create the variety of cells that we need. So we can see how this can get messed up. You're doing this from before birth. And you know, right, the clavicle is going to start that bone marrow hematopoiesis. So this proliferation is going on, creating all those different cells and doing it nonstop. So the fact that it goes on without a mistake for most of us is really remarkable. So we can see why that all of that replication, it can lead to a mutation. And in that case, unregulated proliferation will lead to cancer. Sometimes we can escape the signals for apoptosis. Usually if a cell's not functioning correctly, we say, hey man, go to the grinder. We don't need you. You are a detriment. But sometimes we can escape those signals. And this is kind of included in the proliferation, but self-renewal, we are just making more populations of cells that are deficient in this case. So what I've been saying, normal differentiation is stalled, and then the bone marrow just becomes crowded with these immature, non-functional cells. So really like a worst case scenario for your blood generating regions. All of the signals, those delicate signals that are causing the proper differentiation, are getting gobbled up by cells that aren't doing anything with them. For whatever reason, proliferation has been is no longer regulated. So now I have, hundreds of these. Well, hundreds is probably like millions, like a lot. They're overcrowding. There's not even any space for more cells. So just the geography of a leukemic bone marrow is really congested, crowded, no communication. Like these cells can't hear themselves talk, and they are constantly replicating despite signals not condoning that. We have two types, and I've already referenced this last week. First type is acute myeloid leukemia. So all the cells of the CMP line drop in count. My erythrocytes, my platelets, my granulocytes, really detrimental. By NBEM, I mean neutrophil, basophil, eosinophil, macrophage. So you're like, dang, like I have no defenses now, and you would be right. It's rapid and aggressive onset. And this is usually the one we see in adults. So what can we extrapolate from here? Well, I have no or a very diminished amount of erythrocytes, so I'm going to have some sort of anemia. I'm going to have really poor oxygen delivery. The whole point of a red blood cell is it has hemoglobin. Which binds oxygen. So if I don't have that, well, then I'm not binding oxygen, and my tissue's not getting it. So that's really detrimental, as you could see. Platelets from my megakaryocytes, again, part of the CMP line. Now I can't clot. And now my granulocytes, my entire innate branch of my immune system, right? We talked so much about Unit 1. Yeah, my adaptive immune system's great. It's great, but I need time for it to kick up to third gear. So in that meantime, I need some defenses in play, and if I don't, well, that is horrible. So, let's see. Yeah, infection prone. So all around, really scary conditions for acute myeloid. Really rapid and aggressive, and this is the adult one. Typically, of course, there's always exceptions. Acute lymphoid leukemia is that with the common lymphoid tree. So you have malignant lymphoids, probably those B or T precursors, and this is typically found in children. This is often responsive to treatment, which is pretty cool. But it is really devastating to immunity until then. As we talked about, your innate immune system is excellent at being a first responder. But we need to get to the point of specificity and targeted removal of a detrimental infection. We need proper B and T cells to orchestrate and mediate that response. And if we do not have that, well, immunity suffers. But thankfully, this is quite responsive. I don't know the rate, but I did find positive things to say about this branch of leukemia. Positive things to say about leukemia. What a weird sentence to say. Okay, so yeah, this is kind of how it looks. So typically, right, I have a neutrophil hanging out with my blood cells. I've never seen it spelled that way. That's really weird. Platelets hanging out, that's a good thing. Neutrophil, monocyte, that's a macrophage in tissues. In leukemia, I've got these weirdos everywhere. And look at these. So this diagram actually isn't doing a great job. Some of these don't even look like proper neutrophils or proper lymphocytes. They might have some like issues on them or something representing that they didn't make it all the way to final maturation. They look a bit different. You'll see like pre-neutrophils or pre-macrophages. So they're stuck in the pre-phase as something that this is not really getting. Okay? But it is getting that we have a lot of them in our blood and a lot of them in our bone marrow as well, crowding and clogging with improper signals. All right, so I already said anemia, big deal here. No functional RBCs, so I'm not getting oxygen delivery. Not good. No functional megakaryocytes, so my bleeding risk increases. No first responders, high infection risk. So the main thing here, despite the high white blood cell count, these dudes are not doing their job. They haven't finished proper differentiation, so there's still a profound level of immunosuppression. Right? This is where a bone marrow biopsy comes in really handy. Because if you see this elevated white blood cell count, you're like, well, what's going on? Boom, you take a cross-section, you take a sampling of the site where all of this is generated, and then you're like, oh, well, that's why I have a bunch of improper signals and improper proliferation going on at the site of creation. So, there you go. Full circle. All right. 2 more diseases to go. These are easier to explain, I believe. First up is X-linked agammaglobulinemia. I'm so glad I hit that on the first try. That's awesome. X-linked agammaglobulinemia, also known as Bruton's disease after the physician that uncovered it. So this is a mutation in the genome, specifically the BTK gene. Not worried about that. It causes improper halting of B cell development, so we're stuck at the pre-B stage, meaning these cells are not going to pass their positive selection and negative selection and all that. And what did I say if you fail those? Well, apoptosis. You die. So if all of these are stuck at the pre-B stage, all of these fail, and all of these die. Oh dang, I have no mature B cells that enter my periphery. That's like, wow, that's pretty rough. So just to picturize it here, we don't make it past here. So I don't even get to my spleen. I can't become a mature B cell. So I dang sure can't get activated and turn into a plasma cell. Really rough. I've just completely eliminated an entire arm of my adaptive immune system. Yikes. Yikes. Okay? So the dendritic cells, specifically your follicular ones, so those are the ones hanging out in the secondary immune organs, they never get the signal to establish the germinal center. I don't make the Thunderdome. And what did I say about that? Well, that was really important for making even better B cells. So not only do I not have B cells, I don't have the best B cells. So I don't have any affinity maturation. I don't have any class switching. I don't get to that stage at all. So I can't even make IgG. I can't make IgA. What the heck? And yes, technically, the BTK gene is not going to involve T cells, but their response is also dampened because a secondary role of B cells is antigen presentation. Yuck. My entire adaptive arm is just knocked out now. Sad face. Sad face. No mucosal immunity and horrible bacterial clearance because I lost my main opsonizer. My fork is gone. Really terrible. So we'll talk about on 2.7 the next video, but the only real help here is you have to be on a pooled IgG cocktail. You have to get foreign IgG. We'll go over the real name of it next unit. But you just have to. What we do is we take donor IgG from various populations or various folks. So hopefully that gives you enough of an immune response, an immune protection. But remember, I'm stopped here. So I never get to my terminal plasma stage or my terminal memory B stage. Nothing's creating those antibodies if they're just getting injected into me. So at a certain point, that antibody titer will decrease, and you'll have to get it again. So yeah, really crazy disease. X-linked. So that is going to mainly occur in men. Right? If it's X-linked, we have the XY chromosomal setup. So if we only have one shot. If the X has it, the X has it. For women, if you have the XX, well then hopefully only one X chromosome possesses the mutation on the BTK gene and the other doesn't. So it's very, very unlikely in women. This is mostly a men-dominated issue. All right, multiple myeloma. This is the third disease we're going to hit. This one's really interesting as well. So this is the malignant transformation of a plasma cell, making it undergo rapid proliferation and antibody secretion, thus impairing hematopoiesis. Now you might be thinking, well, the whole point of this unit, you said, was B-cell development, and the terminal endpoint is my plasma cell, my antibody factory. And, well, we want as many of those. We do clonal expansion once a B cell is activated. And then we make a bunch of antibodies. What's wrong with this? Well, this is a good way to test your knowledge of the stages of B cell development. At this point, proliferation should have stopped. We should be done with that. We got activated. We replicated a bunch. We did a bunch of somatic hypermutation, some class switching, some selecting the best of the best. But at this point, I'm done replicating. That's already happened. So the mutation is causing me to kind of go back in my lineage, go back to some of my abilities that I shouldn't have anymore. And I just make a bunch of this B cell. And a bunch of antibodies, well, because that's what they're used for. So what's going on here? Well, now I am secreting all of these antibodies for this antigen, but I am secreting way, way over the amount that is required. So my antibody diversity collapses because it's just overrun with antibodies from this rogue plasma cell. Absolutely overrun. I keep making these antibodies that I just don't need because this cell is cancerous. It is replicating to an unregulated degree and ignoring all of the signals my body's telling it. So one antibody clone is dominating. And this is really bad because we're not telling it, it's not listening to the stop signals. So maybe we get these deposits, these antibodies just start binding to everything because they are everywhere. They start coming out of solution. They are so hyper-concentrated in the blood that they start binding to the walls. And your kidneys, right? Your kidneys get a fifth of cardiac output. They get a lot of blood. And they are your filter. They create the urine. So they're trying to filter out and make sure that your concentrations, your acid base levels, your ions are good. They're going to see you have a metric hecton of this antibody floating around, and they're going to try and get rid of it. And they're going to get exhausted. And now your nephrons are damaged. And now, we're worried about kidney failure. So horrible systemic damage can occur. And also, you can actually these plasma cells go back to the bone marrow, which is not pathogenic in and of itself. Sometimes your plasma cells will hang out there, but they start secreting these weird signals that tell me to break down bone. Break down. So they go back home. They crowd the place because they're proliferating like crazy. They're taking up all these signals and space, so they're messing with hematopoiesis. And not only that, but since they're cancerous and unregulated, the signals they're secreting are messed up too. So now I'm breaking down the bone. Now I'm selecting for bone breakdown. Absolutely crazy. All because we had one mutation occur in a plasma cell. The goal of all of this stuff we talked about this unit, and one mutation absolutely devastates the body. So what does this look like? Well, bone breakdown, so bone pain. My bones are feeling brittle or hurting. That's actually what most folks describe prior to coming in. This is what brings them in. Hypercalcemia. If I'm breaking down bone, well, bone is made of hydroxyapatite, which is a calcium crystal. So now I'm breaking all that down, and that's just going into fluids. So I have more calcium in my blood. So that means I'm hypercalcemic. You might be anemic because you can't your blood cell formation chamber is overtaken by these insane things. And you might not have good innate defenses because I can't get neutrophils out. I can't get basophils or macrophages or dendritic cells because, again, my bone marrow is being overtaken. Crazy stuff. So very bad. Bad news bears. I wanted to make a note, though. What's the difference between clonal expansion? I thought we wanted all the B cells possible to combat my infection. Again, the difference, rapid proliferation. There we go. Rapid proliferation of an activated B cell. That's right here. It's kind of a step before the terminus. Then they differentiate into plasma or memory. So that's a nitpick, but as you can see with this condition, it's really important to know the difference here. Okay? In the case of multiple myeloma, the plasma cell goes back to the activated stage and does proliferation. Despite getting to its endpoint, despite being terminal, it should be done with that now. But it gets confused somehow. So this expansion is antigen independent and it keeps going. Again, different from this. This is antigen dependent. I need it to be activated by my single antigen. And once that antigen is cleared, then my antibody titer, my B cells start to decrease in population. It goes away. This does not. It goes crazy. And the bonus effect of rendering my bone marrow useless because I'm overrun with these unnecessary antibodies. So this is a depiction. Normally, I'll have some plasma cells come back to home and hang out, come back to the hometown and chill. But in this case, we just overrun the body with all of these antibodies that are not following the typical regulation pathways that we discussed. And I'm going to leave you with this last thought. Is this an autoimmune condition? Is this autoimmune? It's a really good thinker. Okay? So start thinking it through. Well, I have cells of my own that are causing an issue. These B cells are becoming plasma cells, and those plasma cells are getting messed up and doing something wrong. Secreting antibodies when I don't need them. But I would say, or I think just objectively, no, it's not. Let's walk through. The B cell was activated against a regular old antigen. So a correct response against something that's not me. So these B cells are creating an an antibody response against a typical antigen. That's fine. They just get messed up in this process and start going absolutely wild. Even if that antigen, even if whatever naturally infected me is removed, I'm still making this antibody. So no. An autoimmune condition would be if these antibodies were tagging me and the response was against my cells. This was technically totally fine. It was attacking an antigen at first. It just became unregulated. So technically, no. Because it correctly identified a foreign antigen, but it went about it in the wrong way. Okay, so yeah, my effector, my plasma cell, the boss that's supposed to get rid of this just got messed up. Again, it should help you appreciate how delicate this pathway is, how delicate making a good, functional, proper plasma cell is. Once we get to that point, that antibody factory, things can still go wrong, and this is the example of that. So no, not autoimmune, just an overzealous hyper soldier just goes off the deep end. All right. So those are my 3 conditions: leukemia, X-linked A gamma globulinemia, nailed it again, and multiple myeloma. So give those a look over. You'll have the weekend to study those, which is awesome. And then on Monday we'll talk about how these diseases are cured, or in most cases just managed. As you can see, these are kind of hard to cure. But thank you again for your continued attention, and I hope you guys have an excellent day. Adios.